For the series f of x equals e to the negative 2x, use the definition to find the Maclaurin series and also find the associated radius of convergence. I feel like that's probably going to be the ratio test. Well, we're using the definition. That means we're going to start taking derivatives. Go ahead and find the first three derivatives, let's say, and then see if you can come up with a general pattern for the nth derivative. Pause the video, come back when you're done with that. I hope you came up with f prime of x is equal to negative 2e to the negative 2x. F double prime is 4e to the negative 2x. F triple prime negative 8e to the negative 2x. Look, we keep picking up a power of 2, and we have a series that's alternating in sign. So the nth derivative is negative 1 to the n times 2 to the n times e to the 2x. Anytime, folks, you have this alternating series situation or, this 2 to the n situation, so anything like that, I highly recommend once you write down what you think it is, double check. If n is 0, I have a positive term. I have a 2 to the 0, e to the negative 2x, that matches. If n is 1, I have a negative term, 2 to the first power. Just double check that the n works out the way you expect it does. We're asked for the Maclaurin series. For the Maclaurin series, we know that a is equal to 0. So we're going to evaluate each of these at 0. F of 0 is going to be 1. F prime of 0 is going to be negative 2. F double prime of 0 is going to be 4. F triple prime of 0 is going to be negative 8. How many of these do we need? Folks, if you're asked for the Maclaurin series, or a Taylor series for that matter, then you need as many as you need before you can recognize the pattern. So, it's up to you. The nth derivative evaluated at 0, I'm confident in saying, is negative 1 to the n times 2 to the n. Or if you like, the base of negative 2 to the nth power. Thinking about things in terms of n, we have the very first one where we didn't take a derivative is n equals 0, and then the first derivative represents n equals 1, and then n equals 2, n equals 3 for the third derivative, and then a general n for the nth derivative, right? Now the Maclaurin series that we're fleshing out would be the sum as n goes from 0 to infinity of the nth derivative evaluated at 0 divided by n factorial times x to the n. We don't need the x minus a because this is a Maclaurin series. I'll just make that an aside, and we're going to wrap this up here. E to the negative 2x is then equal to 1 over 0 factorial minus 2 over 1 factorial times x plus 4 over 2 factorial times x squared, and so on. In sigma notation, and that's really what we're after, e to the negative 2x is the sum as n goes from 0 to infinity of negative 2 to the n divided by n factorial times x to the n. For the radius of convergence, we're looking at the limit as n approaches infinity of the absolute value of 2 to the n plus 1 x to the n plus 1 divided by n plus 1 factorial times the reciprocal of the nth term, n factorial divided by 2 to the n x to the n. All but one factor of x will divide out. All but one factor of 2 will divide out. And n factorial will divide out, leaving us with, from n plus 1 factorial, just the n plus 1. This gives us the limit as n approaches infinity of the absolute value of 2x over n plus 1, which is equal to 0. Therefore, the radius is infinity.